welcome to this comprehensive natural language processing NLP course for beginners. NLP is a fascinating field of artificial intelligence, AI, that enables computers to understand, interpret, and generate human language. From virtual assistants like Siri and Alexa to chatbots, sentiment analysis, and machine translation, NLP is shaping the way we interact with technology. In this course, we will break down NLP into simple concepts, cover technical aspects using Python libraries like NLTK, spaCy, and transformers, and explore real-world applications. Let's dive in. Natural language processing, or NLP, is a branch of AI that deals with the interaction between computers and human language. Is a branch of AI that deals with the interaction between computers and human language. Unlike structured data, such as numbers in databases, human language is unstructured, making it complex for machines to process. For example, the phrase "I saw a man with a telescope" can have multiple meanings depending on context. NLP helps computers decipher such ambiguities. Key NLP applications. NLP powers various real-world applications. Some of the most popular ones include 1. Machine translation. Google Translate converts text from one language to another. 2. Chatbots virtual assistants. Siri, Alexa, and Google Assistant use NLP for conversation. 3. Sentiment analysis. Businesses analyze social media and reviews to determine user sentiment. 4. Speech recognition, converting spoken words into text. For example, voice to text. 5. Text summarization. Tools like GPT-4 summarize articles automatically. Understanding text processing in NLP. Before machines can understand text, they need to process it. This involves tokenization, stop word removal, stemming, lemmatization, and POS tagging. Understanding tokenization is one of the fundamental steps in natural language processing, NLP, that involves breaking down a given text into smaller units called tokens. These tokens can be words, sentences, or even subwords, depending on the level of granularity required for analysis. For example, in word tokenization, the sentence, "Natural language processing is powerful," would be split into natural language processing is powerful. In sentence tokenization, a paragraph is divided into individual sentences. Tokenization is essential because it helps in structuring unstructured text data, making it easier for machine learning models to process and analyze. Modern NLP libraries like NLTK, spaCy, and transformers provide efficient tokenization methods that handle complexities such as punctuation, abbreviations, and contractions. Tokenization is widely used in applications like chatbots, search engines, sentiment analysis, and machine translation, where breaking text into meaningful units is crucial for further processing. Stop word removal is a crucial pre-processing step in natural language processing, NLP, that involves filtering out commonly used words that do not contribute much to the meaning of a sentence. These words include is, the, and, in, on, at, to, and many others that frequently appear in texts but carry little significant information. Removing stop words helps reduce the size of text data, improve processing speed, and enhance the accuracy of NLP models by focusing only on meaningful words. For example, in the sentence, "The cat is sitting on the mat," stop words like the and is can be removed, leaving cat sitting mat, which still conveys the core meaning. While most NLP libraries, like NLTK, spaCy, and scikit-learn, provide predefined lists of stop words, selecting the right stop words depends on the context and application. In tasks like text summarization, keyword extraction, and search engines, Stop word removal improves efficiency by eliminating unnecessary words, allowing algorithms to focus on more informative content. However, in some cases, keeping stop words is essential, such as in sentiment analysis, where words like not can significantly change the meaning of a sentence. Stemming and lemmatization are text pre-processing techniques in natural language processing, NLP, used to reduce words to their base or root form. Stemming is a rule-based approach that chops off word endings to obtain the root form, often resulting in words that may not be valid in standard language. For example, the word running would be reduced to run, and happily might become happily, which is not a proper word. Stemming is faster but less accurate, as it does not consider the meaning of the word. On the other hand, lemmatization is a dictionary-based approach that reduces words to their proper root form, lemma, while ensuring the result is a valid word. It considers the context and part of speech, POS, of the word. For example, running is correctly lemmatized to run, and better is lemmatized to good, because lemmatization understands grammatical relationships. While lemmatization is more accurate, it requires more computational resources compared to stemming. Both techniques are widely used in search engines, chatbots, and text analysis. To improve data processing and retrieval efficiency in NLP applications. POS tagging, or part of speech tagging, is a fundamental technique in natural language processing, NLP, that involves assigning grammatical categories to words in a sentence, such as nouns, verbs, adjectives, adverbs, pronouns, and conjunctions. This process helps machines understand the syntactic structure and meaning of text, making it crucial for tasks like text analysis, machine translation, and speech recognition. POS tagging relies on linguistic rules and statistical models to determine the correct tags, especially when a word has multiple meanings. For example, in the sentence, "She will book a flight," the word book is a verb, while in "I read a book," it is a noun. Modern NLP models use algorithms like hidden Markov models, HMMs, conditional random fields, CRFs, and deep learning techniques to achieve high accuracy in tagging. POS tagging is essential for advanced NLP applications, such as named entity recognition, NER, sentiment analysis, and question answering systems, as it provides critical linguistic context that improves language understanding. Named entity recognition, NER, is an essential technique in natural language processing, NLP, that identifies and classifies named entities in a text into predefined categories, such as persons, organizations, locations, dates, time, monetary values, and more. For example, in the sentence, "Elon Musk founded SpaceX in 2002 in California," NER would identify Elon Musk as a person, SpaceX as an organization, 2002 inches as a date, and California as a location. NER helps machines understand the context of text, making it valuable for applications such as information extraction, chatbots, sentiment analysis, and automated news summarization. Advanced NER models use machine learning and deep learning techniques like conditional random fields, CRFs, Bill's TMs, and transformers, BERT, spaCy, etc., to improve accuracy. Businesses use NER for customer feedback analysis, fraud detection, and knowledge graph creation, making it a crucial tool in modern NLP applications. Sentiment analysis, also known as opinion mining, is a key application of natural language processing, NLP, that determines the emotional tone of a given text. It categorizes text as positive, negative, or neutral, helping machines understand human emotions and opinions. For example, in the sentence, "I love this product, it's amazing," sentiment analysis would classify it as positive, whereas "this is the worst service ever" would be labeled as negative. Businesses use sentiment analysis for customer feedback analysis, brand reputation monitoring, and social media sentiment tracking. It is widely implemented in chatbots, product reviews, stock market predictions, and political analysis. Sentiment analysis models use lexicon-based approaches, machine learning classifiers, and deep learning techniques like LSTMs and transformers, BERT, Roberta, to improve accuracy. By analyzing large volumes of text data, sentiment analysis helps companies make data-driven decisions, enhance customer experience, and predict market trends effectively. Popular NLP libraries. Several powerful libraries have made natural language processing, NLP, more accessible and efficient, providing tools and pre-trained models that speed up development and improve accuracy. NLTK, Natural Language Toolkit, is one of the most widely used libraries for teaching and experimenting with NLP. It offers comprehensive resources for text processing tasks such as tokenization, stemming, POS tagging, and named entity recognition, NER. Another popular library, spaCy, is known for its speed and efficiency in processing large volumes of text, making it ideal for industrial use cases. spaCy also provides pre-trained models for tasks like dependency parsing, NER, and text classification, and it supports deep learning integration. For more advanced NLP tasks, the Transformers library by Hugging Face is a go-to choice. It leverages state-of-the-art pre-trained models like BERT, GPT, and Roberta, which can be fine-tuned for specialized tasks such as question answering, text generation, and language translation. These libraries, each with its unique strengths, empower data scientists and developers to perform complex NLP tasks more easily and efficiently, and they are widely used in AI research, chatbots, machine translation, and more. The future of natural language processing, NLP, holds exciting possibilities, driven by advancements in deep learning and AI technologies. As models become more sophisticated, NLP will continue to improve in understanding context, capturing nuances, and handling diverse languages and dialects. The integration of transformers and pre-trained models like BERT and GPT is transforming industries, enabling more accurate and efficient applications in fields such as healthcare, finance, and customer service. However, despite these advancements, NLP faces significant challenges. One of the main obstacles is bias in NLP models, where systems may unintentionally reflect societal prejudices found in training data, leading to skewed or unfair results. Additionally, multilinguality remains a complex challenge, as models trained in one language may not perform as effectively in others, especially for low-resource languages. Contextual understanding and ambiguity in language, where words or phrases can have multiple meanings depending on usage, are also ongoing hurdles. The ethical implications of NLP, such as the potential for misuse in surveillance or misinformation, will require careful consideration as technology progresses. The future of NLP promises continued growth, but addressing these challenges is essential to ensuring that NLP technologies are fair, accurate, and responsible. Thank you for watching this comprehensive guide on natural language processing. If you found this content helpful and insightful, don't forget to like, subscribe, and share with others who may benefit from it. Your support helps us continue creating high-quality content to assist you in your learning journey. Be sure to hit the notification bell so you never miss out on future updates and new videos. If you have any questions or topics you'd like to see covered, feel free to leave them in the comments below. Keep exploring, keep learning, and I'll see you in the next video.